welcome to yet another episode about BERT, indeed the Deep Bidirectional Transformers for Language Understanding Model, or BERT, has had a significant impact both in the academic literature as well as in industry, and in almost record time. And although BERT's gotten quite a bit of press, I think it's worth noting that it is one of many milestones, or I suppose a stepping stone, another of which, ELMo, we covered on a previous episode. And if I asked BERT, well, in fact, I can do that right now. Let me ask BERT. You know, these modern language embedding models like BERT are all about next word prediction. So what if I ask it to predict what comes after ELMo, BERT, Will it say GPT-2? Well, let's find out. Not even close. ELMo, BERT, Ilex, Oleg, Sean Fang Feng, and a list of other names, some of them familiar, some of them gibberish. Oh, let's take a step back and talk about what I'm doing here. So BERT is a pre-trained model. And actually, let's take a little sidebar here for a moment. These models require a great deal of not only training data, but computational cost to produce. Now, the interesting thing about cloud computing is that those resources have been democratized. If I wanted to, I could go right now, I could spin up 100, 200, maybe even 1,000 computers, virtual machines, with one of the major cloud providers that I have accounts with. I've never tested it, but I imagine they have some idiot-proof system where I couldn't try and spin up 100,000 machines, because, I don't know, maybe they know I couldn't pay for it, or they presume it's a mistake because it's too many all at once, compared to my past behavior. But hypothetically, limits like that aside, access to raw compute and distributed computing especially is no longer an ivory tower thing or a silver spoon sort of thing. Well, I guess it is actually, because insofar as cloud computing has democratized it, and even commoditized it, right? The prices are often driven down on spot instances and stuff like that. At the end of the day, you pay for compute. It is becoming like a utility. And I heard somewhere, and gosh, I wish my notes had better annotations so I could remember where I got this little nugget of wisdom, because I have not been able to find the source. But someone estimated, and ballpark, I'll call it close enough, this is probably right, but they estimated that OpenAI, when they trained their famous GPT-2 model, which is somewhat analogous to BERT, that the computing resources required would have cost $45,000. Now that's a really interesting amount to me. First and foremost, because it is a lot of money. And if you think $45,000 is a small amount of money, please become a supporter of Data Skeptic. We will gladly accept your endorsements. But at the same time, $45,000 is, and I don't mean to sound crass here, but it's also not a lot of money. I know we have a lot of young listeners, undergraduates and things like that, and I remember when I was an undergraduate, I would not have understood this part of the show right now, but you'll understand when you guys get older. It's a lot of money, but it's also not. If you need to acquire that, a person could do it. In a business, they ought to have no problem raising that amount of money. So, training a model like GPT-2 or BERT, it's feasible, but also not. And while in the dark mirror version of the universe, maybe these corporations have locked up these models and kept them to themselves and built this economic barrier to entry, in this universe, Google has published their model, and I believe other organizations have as well. Now, whether or not that will continue is a very interesting question, perhaps for another episode. But as it stands, that model's published, and there's no getting rid of it now. I've got a copy cached. I can leverage the BERT model to do transfer learning, or just out of box to do some automated feature engineering on my natural language processing problem. So as we've talked about on previous episodes, as BERT debuted, it smashed all of the established benchmarks on a wide array of seemingly different natural language processing tasks. Things like question and answering tasks, and next word prediction, and a variety of others. And from a personal and hands-on point of view, as I told you about a couple episodes ago, my personal take is that BERT is magic. And in the next episode, or maybe the one after that, hopefully I'll be talking to one of my colleagues about our use case and what we experienced in practice working with BERT. But the long and short of it is, for specific natural language processing tasks, given that this was open sourced and is quite powerful, it's almost becoming the de facto standard for NLP tasks. Get your BERT embeddings and move along from there. Feature engineering has been automated. But one of the challenges to working with BERT in practice is that it's actually quite large. There are two different sizes published. The small one, as I recall, takes about 8 gigabytes of memory, the large taking about 16. And while, most of you, or anyone listening on a desktop computer, may very well have that amount of memory in your computer right now, no problem to fire that up, load it, and work on your project. But in terms of putting that in any production system, you need a little bit of a beefy machine, and in most cases you're going to want a pool of those and a load balancer, and suddenly the costs are, let's just say, non-trivial. Thinking of future-proofing your job? At Flatiron School, ranked #1 coding bootcamp by Course Report for 2019-2020, you can learn the technical details you need to launch a career in tech as a data scientist in just 15 weeks. With support you can count on, Flatiron School's dedicated career coaches will work with you one-on-one and help place you in a brand new job or your money back. Does your degree come with a guarantee? Complete details at flatironschool.com/terms. Pursue your passion, discover your potential, and choose to learn online or at one of their global campuses. Visit flatironschool.com/dataskeptic today. That's flatironschool.com/dataskeptic. So in our coverage of BERT, or I guess really what I want to cover is language embedding models in general, because we're going to be talking mostly about GPT-2 today, I wanted to find some interesting way of covering it, in an audio format appropriate for the podcast. My original thought was, why don't I get some transcripts and have actors read them, much like what we did on our imitation game episode last year. But yeah, we've already pulled that trick, and the results would be much the same, although I thought maybe I'll try some things in real time and share them with you, and just give a few candid observations. So I'm going to head over to a site I was pointed to by the guest we'll be talking to in a little bit. Fire up your browser and head to talk2, that's the word TO2, talk2transformer.com. There you will find that someone has gone through that somewhat arduous task of spinning up a embedding model and holding it in memory so that users of a website could query, presumably some API, and get embedded results. So I've been brainstorming different ways that I might be able to put you, the listener, in a at least voyeuristic conversation between myself and BERT or GPT-2 or one of these large-scale bidirectional embedding models. And I was pleased that I found a blog post by the guest we'll be talking to momentarily who pointed me to a site called talk2transformer.com. And that's 2 as in TO, talk2transformer.com. And the creator of this site has set up a way in which you can enter some prompting text and see what the smaller GPT-2 model would produce as the predicted next statement. I say the smaller GPT-2 model because the organization that created that, OpenAI, elected to release only a limited version, not the most extensively trained version that they produced. Their rationale being that it was too dangerous to release, as though nefarious people could leverage it to produce especially good, fake news or fraudulent documents or who knows what, and maybe the who knows what was what led them to that choice. I'm not going to judge it either way. And of course, I can't talk directly to their advanced model, but luckily I can talk to this one at talk2transformer.com and get a bit of a feel for what's going on with the model. And I thought I'd share a few observations with you guys. First and foremost, what I noticed is that the responses have a peculiar sort of overfitting to them, which is interesting. Let me give you a few examples. I took the classic Lewis Carroll line, "'Twas brillig with slithy toves," and presented that as the primer sentence. And what I got back was something very evocative of the New Testament or Old Testament, the Bible, which reads as such, "'Twas brillic with slithy toves, who wrought it. The Lord spat unto Moses, saying, Take the seed of Soma of the Canaanites to the 10th day's labor, and let all his people dwell in the land, and take the first fruits of their labor," yada yada goes on, even starts new paragraphs with sequential numbers, 13, 14, 15. Bears all the hallmarks of like a really bad forgery, in a way. I thought, okay, let's really put one of these models to the test. What would I most like to know as the next sentence? So here's what I came up with. My prompt was, "Then he revealed the great insight which allowed him to prove that P was not equal to NP, and that insight was," the response to which I got was, "that as far as I can tell, this theorem proves that every formula is a proof of a property." And then there's a sort of gibberish expression that looks very much like LaTeX, and I think might actually be valid LaTeX, while it's nonsensical in its form regardless. And then, oh, this is delightful. It ends, "In other words, the statement P equal NP is derived from the statement P equal NP. What if it was not? The above proof only proves that P equals NP, but it fails to prove that." This is actually surprisingly wonderful in a weird circular way. I didn't know I was going to get this entertained by this. So as it turns out, I'm not the only one who's curious about interacting with these models and talking to them and seeing what kind of results you would get.
Okay, I am quite puzzled by your choice of me.
That's Vazgen Davidyants.
I know what your show is about, computer science, etc. And I am not a developer, I am not a researcher, I am just a guy who tricked GPT-2 into working as a chatbot.
I read a blog post he wrote up about his experience chatting with the GPT-2 model.
I just thought GPT-2 is a very promising algorithm for generation of text. I saw the unicorn story and it was awesome. I wondered what could GPT-2 do if it was used as a chatbot.
Were you impressed with the results, or did you find it to be an unimpressive piece of software?
To be honest, a little of both. I was impressed by it, but when I tried to learn something from it, when I hit the wall, I noticed that using GPT-2 as a chatbot looks like talking with a person until you try directly address something in speech, or when you try to learn something from it.
Why is it so gosh darn interesting to talk to GPT-2, or talk to BERT or ELMo or any of these language models? Well, despite the fact that BERT, at time of publication anyway, set new gold standards on a wide array of seemingly independent natural language tasks, and subsequent models like GPT-2 seem likely to continue to push those limits as they take the same basic neuroarchitecture and train it on more heterogeneous corpora. Truly, I don't think we've seen the limit yet of just shoving more data down the throat of this algorithm. But I do think there is a limit there. I don't think shoving enough data down the algorithm's throat, to belabor the analogy, I don't think that would ever get us to artificial general intelligence. I think there's a series of other novelties, probably necessary to be figured out by researchers before we get anywhere near that, in addition to, of course, the scaling up. Let's put it to the truest test, the Turing test, or as I like to call it, not to take away anything from the father of computer science, Alan Turing, but I prefer his title, The Imitation Game. And to be a bit pedantic, what Vazgen is doing here, and what I was doing earlier, is by no means an example of the Turing test. because the imitation game requires a judge and two participants, one actively engaged in the act of deception, and the judge informed that they need to assess which conversation partner is a machine versus a person. However, talking to a chatbot is at least directionally correct. Talking to a chatbot and getting convincing conversation must certainly be some sort of pre-qualifier. Okay, so I'll try and make this quick. Searle's Chinese Room.
Did you hear about so-called Chinese room?
Yes, Searle's Chinese Room, of course.
Yeah, that title does make me a little uncomfortable, but I promise you it's not really racist. Although it absolutely comes from a Western perspective, so think of yourself, like myself, as someone who reads English or similar language, Spanish, Italian, French. You know, I can understand a bit of those languages. If I'm traveling, I can, recognize certain words that overlap with my language. I mean, I took some Spanish in high school. Mostly I was just doing math homework in the class, but I managed to absorb a few words. I could survive in a Spanish-speaking country. I can't read it, but, I can get some high-level stuff. But imagine me as a person inside Searle's Chinese Room, which is a sort of a version of the Turing test. However, instead of a machine as one of the conversation partners, there's me, a human runner, in a room with some incredibly long hallways, all filled floor to ceiling with books. These books are shockingly well indexed. And in the middle of the room is a computer terminal and a little printer. For some reason, this feels very 1980s in my mind. So imagine a printer with tractor feed and a very loud print head. And it uses some ASCII characters in a clever way to print out the best semblance of Chinese characters it can produce. And those characters are enough for me to go look them up in the index. From the index, I know the book I want to retrieve that has the best response. I go get the book, turn to the prescribed page, go to the terminal, and okay, I key all those in, and that response goes out to what I know is a human person who can type and read in Mandarin sitting in another room. And I'm playing the role of the machine. And in some sense, I'm no different from a computer bus, or a memory system. In this scenario, I'm just doing it from sort of a sneaker net as I walk back and forth.
Yes, some philosophers argued what person who was in the Chinese room didn't know Chinese, but that person was a part of a larger system, namely this person plus books with rules about Chinese. When combined, this system did know the Chinese, unlike the person who was in that room.
So this was the first time I heard an idea like this. And I don't know that it's Vazgen's original idea, but he's the one who introduced me to it. So variation on the Chinese room. Forget about the Chinese characters. We'll communicate in English. But the possible responses will be generated by some algorithm, and maybe there'll be 3 or 5 or 10 choices, and as the human participant, I need to pick from amongst those responses what is the one that I think is, most likely to win at the imitation game. Now, if I'm served up sort of random garbage sentences from some Markov model, which is obviously something very inferior to what BERT can do, then garbage in, garbage out. But if BERT by chance, 1 out of 10 times produces something applicable and appropriate, and I bring my intelligence to the table and can identify the applicable and appropriate response, then it's quite possible that this hybrid system of GPT-2 suggestions and my curation of them could one day pass the Turing test. Well, not really, because it's no longer a machine, or unless you count me as a machine or as a cog in that wheel, which I guess you can, I sort of am.
This is quite an interesting idea. What maybe GPT-2 doesn't have consciousness, but what about the system where he generate text and I select appropriate replies? Does the system have consciousness? This system isn't equal to GPT-2 or even to me. This is combined intelligence, you could say. I brought it up also because I think that corporations are possibly another form of artificial intelligence. When people think together, if very many people combined intelligent maybe can be super intelligent, it can generate very high quality ideas that are unlikely for one person to generate in raw.
In contrast, what do you think of ant colonies?
Maybe I am not sure. Also, form of group intelligence, or maybe not. Maybe it is something like neural network that runs on the ants. If you understand what I mean.
I think so, yes.
Just imagine an AI that manages a corporation for profit who is able to detect, for example, loopholes in laws in order to exploit them to maximum degree. This AI will be able to outsmart the state. States are too slow, and many human-driven corporations will be slow too. It would be able to adapt itself to its very possible responses even before they even think about responding. Such AI can outsmart the whole market, outsmart its opponents in political games, and this can bring very interesting results too in society as whole.
Are you familiar with the P versus NP problem?
I heard something about this, although I don't remember. Can you give me a refresher?
Sure. It's the central problem in computer science. If you were to solve it, you will be famous in one day, like Albert Einstein. It is so important. Algorithms are classified into groups based on the runtime. We call it big O analysis. Do you know what binary search is?
Not yet.
You are interested to know if a technical word appears in a standard dictionary. A bad way to do it is to go to the first page and check each word, then go to the second page and check each word, and go through the entire book in a linear fashion. A smarter way is to go to the middle of the book and say, should my word be to the left or to the right? With one check, one computation, you cut the problem size in half. And then you recursively cut it in half again, and you solve it very quickly because the problem is getting one half each time, which is like a logarithm in mathematics. So a problem that runs in logarithmic time is very simple. We also consider problems that run in polynomial time to be practical, but there are problems that cannot be solved in polynomial time, and these are rather intractable. It's unlikely you can solve them. The famous open problem is whether or not a certain class of very hard problems can be solved in polynomial time. And we don't know the answer, but we're pretty sure, we're like 99.99999% sure that they're separate classes. And if that's true, then there exist hard problems in the world. And even a super intelligent AI will not be able to solve those problems any better than us. So I think the super intelligence you're envisioning would have the property of being able to constantly generate very good ideas. But it might be that generating good ideas requires chance.
Yes, this is true. But also, you can think about possibility with AI won't be just generating very good ideas how outsmart people in the market and politics. It will use its superior rationality to beat people. You know, people have tons of biases, and that and I would have biases what people have, making it more competitive, if you understand. Like it wouldn't have sunken cost fallacy in its thinking.
Sure, it might be much more rational, at least for as much computational power as it can muster. Because the smarter it is, the more energy it will require.
Yes, it is true. But I think what maybe new computational platform will allow for more efficient computations than today. For example, quantum computers.
Yeah, so I know a little bit about them. I had the opportunity to interview a well-known quantum computer scientist named Scott Aronson. He wrote a wonderful book called Quantum Computing Since Democritus. And one of the main points he shares is that quantum computers in the popular press are talked about like they're magic and they will make everything better. But actually, they are better than classical computers for sure, but in a couple of very specific ways. Like there are two algorithms, Shor's algorithm and Grover's algorithm are maybe the two most famous. But it's not true that every quantum thing can take advantage of a quantum computation. We don't know. Maybe the things to be super intelligent can't take advantage of quantum calculations.
Yes, but what about possibility what in the future we will develop algorithms what will exploit advantages of quantum computing platform? How about this?
At some level, you have to get the physicists involved because there are limits here. The machine won't be magic. It's still bound by nature.
Yes, of course. I think there is potential for computations just getting cheaper.
Yes, that's very true. Yes, very cheap.
Yes, and when even without a revolution, cheaper computations allow for better intelligence.
It's not necessarily true that follows. We don't really know exactly. So far, we know that, at least with deep learning, it seems like the more we add, we're getting a benefit, but there could be a ceiling that we don't know about yet.
Yes, it is true, but I am more optimistic about it.
I am too, yeah.
I mean,
just playing. Yeah, go ahead.
I mean,
And in fact, that cheap computation facilitated by commodity hardware in the cloud has really made it possible for us to establish these large-scale pre-trained models. And while the ones we have today accomplish a great deal of interesting tasks, they certainly still have some limits. The interesting part of the story is going to be whether or not those limits are surpassed by simply more and more data, or if something from a methodological point of view is lacking in all of the best current approaches. I don't have the answer, but I'm after it, so stay tuned to Data Skeptic and maybe we'll find it together. Good night, everybody.